Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. In the second part, we are going to discuss on the properties of Laplace transform. Okay, the properties of Laplace transforms are as follows. Okay, the first one is linear operation, in which when you have variables multiplied in time domain, so the same variables or parameters will be multiplied in S domain as well. So in here you may notice that f1t is multiplied by a and f2t is multiplied by b, so the same variables will be multiplied in S domain as well, a for f1 and b for f2. So from this example, when you use the first principle, so by integrating the function f1 and f2, so you'll notice that the output in S domain yields a multiplied by f1 and b multiplied by f2. Okay, another example on linear operations, in which when you are given ft as cos at, so in exponential function given by this equation, so this equation can be expanded into this. Therefore, you can find the Laplace transform for ft, meaning that you need to get the fs. So refer to the Fourier transform table. So find the Laplace transform for each of this function. So from the table, when you have e exponential function ut, so in S domain it will be 1 over s plus a. So compare the given equation with the one in the table. So you'll get the output in S domain, because the question asks you for Laplace transform only. Let's look at another example. So given fs, and you need to find the inverse Laplace transform for fs, meaning that you need to get the ft. Okay, so in order to solve this, you need to use the partial fraction expansion, so in which this equation is grouped into two components in this case. So you need to find the value of a and b. So from the calculation, you should get the a equal to 3 over 2 and b equal to minus 3 over 2. So now replace the a and b values into the equation. So you should get this. And next, to get ft, so you need to perform inverse Laplace transform. So refer to the Fourier transform table. Look at the shape closest to this one and this one. So from the table, 1 over s plus something will be producing e minus at ut in time domain. So compare your equation with the one in the table in S domain, so that you can identify what is your a. Okay, so perform the inverse Laplace transform both sides. Okay, the first one and the second one. So compare with the given equation, in this case 1 over s plus a. So your a in this case equal to 3. Therefore, this one will produce e minus at ut. In this case, this one will produce, since your a equal to 3, positive 3, so e negative 3t ut. The same goes to the second component. So you have your 1 over s plus 1. So in this case, your a equal to 1. Therefore, this one will produce e minus, your a is 1 t u t. Okay, so your answer, you should have 3 over 2 e minus 3t, supposed to be negative, and 3 over 2 minus e minus t. So this should be your answer. Properties is time shifting. So when it's mentioned time, meaning that time-based operation inside the bracket, so that's shifting. The signal in t being shifted in time by a. So in S domain, the signal in S domain will be multiplied by exponential function e minus as. Okay, let's look at this example. Find the Laplace transform for this impulse. So given the equation ft equal to 1 from 0 to c. So you have from 0 to c, the magnitude is 1. So otherwise it is 0. So you have this signal. Okay, so what is the unit step function for this equation? So this is your ft. So ft equal to, the magnitude is 1. So ut minus ut minus c. Okay, so this is the equation for the given function. So the question asks you to find the Laplace transform. So you need to find what is your fs. So wait, what is your fs? So in order to do that, you need to refer to Laplace transform table. So given ut from the table, ut minus a in S domain will be this equation. Okay, so from this equation, if you break the equation into components, ut will be producing 1 over s in S domain, while ut minus a will be producing 1 over s multiplied by e minus as. So from here, you'll notice that the basic function is ut. That's why it produces 1 over s. But then since that's shifting by a, so the equation being multiplied by e minus as mentioned in the time shifting definition. Okay, so from this equation, so now you can find what is the Laplace transform. So ut, you know it is 1 over s, ut minus c means that 1 over s e minus as. So in this case, t minus a. So your a equal to c. Okay, so your a equal to c. So it is 1 over s for ut. And again, 1 over s again for ut. The shifting property you'll be having the exponential function of as. So in this case, your a equal to c. So replace a with c. So this is your Fourier Laplace transform of ft. Let's look at another example. So in this example, you've been given fs. So you need to find the inverse Laplace transform of fs, meaning that you need to find the ft by performing inverse Laplace transform. So you can break down the equation into components. So it is equal to 1 over s squared minus 2e minus 2s 1 over s squared. Then refer to the table. So you may notice that when you have s to the power of 2, so from the table it's supposed to be t to the power of n ut. So in S domain it will be n factorial divided by s to the power of n plus 1. So compared to the one you have, 1 over s to the power of 2 is 1 plus 1. So you know your n equal to 1 in this case. So in this case, it is t u t. Okay, so you know that in this component in time domain it is equal to t u t. So for the second component, okay, you still have tut. So this is t, but you have the exponential function here. When you have exponential function in S domain, so meaning that you have time shifting operation in t domain. Okay, so you know that when you have u t minus a, so in S domain it will be 1 over s e minus e s. So in this case you have e minus 2s, so your e equals to 2, so it is ut minus 2. So in this case all t will be deducted by 2. So in this case the equation becomes t minus 2 ut minus 2. Okay, so therefore the inverse Laplace transform for this equation, so L inverse Laplace transform of Fs equal to Ft, in which this is equal to 2t minus 2t minus 2 ut minus 2. So this is the inverse Laplace transform of Fs. Okay, next properties is time scaling. So when you have the signal in t being scaled by a, so in S domain the signal will be modified by in the amplitude and also in the frequency. All s will be divided by a. So if you have more than one operation, so you have time scaling and also time shifting. So therefore in S domain the signal will be modified by having a modification in the amplitude, and also since that's shifting in time domain, so the signal will be multiplied by exponential function as well. Okay, another properties is frequency shifting. So frequency shifting meaning that you have the signal being shifted in S domain. So when you have the signal being shifted by A, so in time domain you'll notice that the signal being multiplied by the exponential function. So try this out. Okay, another properties to be considered is the convolution. If you still remember in the first chapter, there's convolution in time domain, so in which you need to perform multiple integration to get the final output. However, you can simplify the operation by considering frequency domain steps, either by using the Fourier transform or Laplace transform. Okay, if you have convolution in time domain, so this is by using first principle, you perform the integration, or if you use the Fourier transform or Laplace transform, the convolution in time domain can be simply solved by multiplying the signal in frequency domain, either in omega or in S domain. So in this chapter, we are focusing in S domain. So you can solve the convolution in time domain by multiplying the two signals in frequency domain. Okay, let's look at the example. Find the convolution of the signal xt with itself. Okay, meaning that your signal xt convolve with itself. Okay, so you need to use Laplace transform to solve this problem. Okay, from the previous page, find the convolution of the signal xt with itself, meaning that you have ht equal to xt convolve by itself. Therefore, from the table, you know that hs is equal to xs multiply with xs. So you have the xt equation, so you can get the xs. So xt equal to ut minus ut minus 1. So by referring to the table, so your xs equal to, when you have ut, the Laplace transform will be 1 over s minus, again 1 over s, and the time shifting you'll be having e minus 1s. So this is your xs. So to solve the convolution, so your hs equal to xs multiply with xs. So it is equal to 1 over s minus 1 over s e minus s multiply with the same function. Okay, so you need to solve this until you get the final equation. So hs is equal to 1 over s squared minus 2e minus 2 minus s divided by s squared plus e minus 2s divided by s squared. So in this case, so to solve the problems, you need to reconvert the s domain function into t domain. So you need to get the hd. So in solving time domain operations, usually you need to solve until you get the time domain function back. So in this case, you have been given the function in time domain, but you need to use Laplace transform to solve the time domain problems. Once you have solved using the s domain, then you need to get the time domain function back. So in this case, inverse Laplace transform of hs is equal to hd. So you need to perform inverse Laplace transform for the 1 over s squared minus inverse Laplace transform of the second component 2e minus s divided by s squared plus inverse Laplace transform of e minus 2s divided by s squared. Okay, as the previous example, so when you have 1 over s squared, it is equal to the t function. So this is equal to t ut minus, you have the variables 2, again t, when you have exponential function, so you know the signal being shifted by a. So in this case, your a is 1 minus 1 ut minus 1, and then plus again another t function, but now the a is 2, so t minus 2 ut minus 2. So this is your ht. So when you plot the function, you should get is tut, so this is t, so this is ht equal to xt convolve with xt, you should get triangular t. Okay, next properties in Laplace transform is differentiation. So if you refer to the table, so if you have a function of df over dt, so it will produce sfs minus f naught. So this df t over dt can also be represented as f prime t. Okay, so when you have f prime t, so in s domain, so this is to the power of 1, so this symbol single prime, meaning that you have only the power of 1. So your s is to the power of 1, fs minus, until you no longer see the s in the function. So this is s to the power of 1, next is s to the power of 0 equal to 1. So f naught. Okay, so here you have s to the power of 0 equal to 1. Okay, so when you check with first principle, when you perform integration of the differentiation function, so you'll get the same answer as fs minus f naught. Okay, for higher order differentiation, so when you have the power of 2, meaning that your s should have the power of 2, the maximum power of 2, and then it reduced to the power of 1, and then s to the power of 0. And the f will start with fs in the maximum power, reduce to f naught, and then it become f prime, next is f double prime, and so on. Okay, so for example, if you have this one can be represented as to the power of 2, so is f double prime t is equal, in s domain it will be s, this is double prime, so to the power of 2, so fs minus, now s become to the power of 1, f naught minus s to the power of 0, f prime naught. Okay, now s already in the power of 0, so you don't have to add additional function. Okay, let's look at when you have triple prime. So when you have the power of 3, so now it is f triple prime t, so in s domain it will be s to the power of 3 fs minus s to the power of 2 f naught minus s to the power of 1 f prime naught minus s to the power of 0 f double prime naught. Okay, so same goes to when you have the n power, so the s power will be reduced until it is s naught. Okay, let's look at this example on differentiation. So you have x double prime, this one is x prime, and this one x to the power of 1. So you need to solve by components. So this is the first component, the second component, and the third component. So when the equation is equal to 0, it is basically the homogeneous equation. So now let's start with the x double prime t. So double prime means s to the power of 2. So it is for the first component s to the power of 2. So xs minus s to the power of 1 x naught minus s to the power of 0 x prime naught. So this is for the first component, and then plus the second component. So plus the second component is x prime. So x prime is to the power of 1. So you have here is 3. So x prime s to the power of 1 xs minus s to the power of 0 x naught, and then plus the third component. Okay, plus the third component okay, the third component you have 2, so there's no prime, so x to the power of 1 only, so it is no s since there's no prime, so it is only xs, and this is the third component, so it is equal to 0. So this is the third component, and this is the second component. Okay, next you need to replace x naught equal to 1 and x prime naught equal to minus 4 inside the equation. So in this case, x naught equal to 1, x prime naught equal to minus 4, and this one x naught equal to 1. Okay, that's it. So replace those values inside the equation. So you should get something like this. Okay, so then simplify the equation until you get the equation for xs equal to this equation. Next, you need to perform partial fraction. Partial fraction expansion. So you have the xs equal to s minus 1 divided by s squared plus 3s plus 2. So in which this one is equal to a divided by s plus 2 plus b divided by s plus 1. Okay, so solve for a and b. Replace a and b inside the equation. Then perform inverse Laplace transform of xs. Then you get the xt. So this is your xt. Okay, let's have another example on differentiation by using S domain. So you need to try and solve this out. So the answer is as shown. So you can just give you a quick step. So yt plus 2y prime t plus yt equal to 2. So this is inhomogeneous equation because the equation is not equal to 0. So you can solve for components. So you have 3 components again, 2 and 3. So don't forget to solve for each component. So y double prime, meaning that you have s to the power of 2. So this is ys minus, don't forget this one is minus s y naught minus normal s to the power of 0 y prime naught. Okay, plus the second component is 2 y prime, so single prime, so s to the power of 1, so ys minus s to the power of 0 y naught. Okay, and then plus the third component. So the third component is no prime, so there's no s, so it is only ys equal to 2. And don't forget 2 is in time domain. So when convert 2 into s domain, it will be 2 ut, it is equal to 2 over s. Okay, next replace y naught and y prime naught with 2. Y naught equal to 3 and y prime naught equal to 2. So y naught equal to 3, y prime naught equal to 2. Same goes to this one, y naught equal to 3. So next you need to simplify the equation until you get your ys equation equal to what? Next, perform inverse Laplace transform of ys to get your final answer in yt. Okay, next properties is the integration. So refer to the table. So when you have the integration of ft, so in S domain it is equal to fs divided by s. Lastly, complex frequency shifting. So when you have shifting in frequency, so same goes to frequency shift property. So you'll be having exponential function multiplied with your signal in time domain. So you can try this out. Okay, next slide is the last properties on modulation. When you have a function multiplied by sine or cosine function, so the Laplace transform is as follows. Okay, so you can refer to the table in which omega is the real values. Okay, next is the from slides 20 to 26 is basically a recap on partial fraction expansion. So I suppose that you have learned this in mathematics. Therefore, you need to recap or revise back your partial fraction in order to solve the problems in S domain. Okay, later I'll provide you more examples to try out. So please make sure you have your Laplace transform table in hand. So try to derive the equation and solve the problem by using S domain function. Thank you.